Hi everybody, Patrick here from EngineeringShop.com, PaintballProps.com, and EscapeRoomElectronics.com. This is the fourth project for the Arduino Playbot, currently on Kickstarter, linked below. If you've been watching the series, the last two videos have been a basic clap-on, clap-off circuit. The second last video is a clap-on, clap-off circuit with adjustable sensitivity. And this one is, this is the final clap project, and it requires 2 claps to turn the relay on, 2 claps to turn the relay off, and we will be able to adjust sensitivity on power up using that variable resistor. Now if you haven't watched the previous 2 videos, I suggest you do that. They are linked below. And the reason why I suggest that you look at those videos now is because I've already discussed the microphone circuit, the variable resistor circuit, the relay circuit, and in the first video I talked about the LCD. So first things first, what I'm going to do is I'm going to set up for this project. And to do that, I'm going to turn on the LCD. I'm going to ignore dip switch 1 on the LCD control dip switch because that is the software control for the LCD backlight. I'm going to manually force that on with this jumper in a second, so I'm going to switch on 2, 3, 4, 5, 6, and 7. And that connects GPIOs 4 through 9 to the data pins for the LCD, as well as the RS pin and the E pin, the enable pin. I'm going to force the LCD on by shorting the EN jumper right there, and I'm going to select mic on the jumper here, not LDR. And lastly, I'm going to turn the RLY dip switch to the on position, and that will enable the relay. Now, in the previous 2 videos, we've talked about also how to connect your relay to an AC control device. In the last 2 videos, we used a lamp. We're not going to hook that up again. Again, if you want to know more about that, please watch the last 2 videos. So, let's look at a demonstration. How this software works is on power up during the void setup area of the code. I'm going to turn off the lights in a minute just so you can see the LCD a little bit better. It looks great to the human eye, but with the light in my lab, it's a little bit difficult to see the LCD on camera. So I'll turn off the light in just a minute. But during the void setup area of the code, it calls a function that allows for us to adjust the sensitivity level of the microphone. So at sensitivity level 10, it's the least sensitive, whereas sensitivity level 1 is the most sensitive. I'm just going to leave it at level 10. And of course, we discussed how this works in the previous videos, how the variable resistor, depending on which way it's turned, offers a different analog value to one of the analog pins. So I'm just going to choose sensitivity level 10. Now I'm going to turn off the light after selecting it. Wait for claps. At the very top of the code, we also declare a Boolean function, and this Boolean function is either true or false. And this helps us to know what state of the software we're in. At the beginning of the software, that Boolean function is false. After we clap twice, the relay turns on, and that Boolean function is turned to true. So after that, it scans the area of the code, waits for 2 more claps to turn the relay off, and essentially reset the software. So I think you can see that quite well in the dark. I'm going to clap twice. Relay on. And now it waits for me to clap again to turn the relay off. Relay off. Now, if I clap once, nothing happens. And that's because after the first clap is detected, there's a timer function and a for statement. And the for statement runs its course, and if it detects another clap during that essentially timer program, then it triggers the next area of the operation. Whereas if it doesn't, during that time period, it doesn't detect another clap, it waits for an initial clap again. So, nothing. Nothing. Relay on. So it's a relatively simple program. If you've pledged towards the Kickstarter campaign, again linked below, at the end of the campaign, all of the code will be fully commented for all of my projects. And right now I've got 12 projects on the go, and I'll be creating several more as the Kickstarter campaign progresses. And our next project is a fun and simple way to create a software reset using one of the analog pins. And what's neat about that project is doing a software reset with an Atmega 32 APU using the Arduino bootloader, using the Arduino program. It's difficult, and you can use some of the digital pins to cause essentially a software-hardware reset, but it's more difficult and you need extra hardware. Anyway, I'm going to get to that video next, and it's a fun and very, very easy way to create a software reset using one wire and a pull-up resistor. So thanks for watching. The commented code will be available at the end of the campaign, and if you haven't already watched the first 2 clap videos, they are linked below. Thanks for watching, everyone.